This is an Algebra 1 video about quadratic. And what we're going to do is we're going to look at the graph of the parabola and how it relates to the discriminant. So let's hide the discriminant for a minute and let me explain the sliders that I have here. This slider is adjusting our leading coefficient a. And you can see that as I change the value of a, which is set up to be only integers for this example, you can see the effect on the graph. There's another slider here for our linear coefficient b, and as I change the values of b, the value of b, the graph changes accordingly. And our constant c also has a slider, and if you didn't already know, this changes the location of the y-intercept of the graph. Alright, so at the moment our discriminant, which is b squared minus 4ac, equals positive 5. Now what does that tell us about solutions of the quadratic? On this page we're going to look at the three possible cases for what b squared minus 4ac could give us. We could get a positive discriminant. We'll come back to that in a second. We could get a value of 0 for the discriminant, or we could get a negative value. Now let's look at what we have. At the moment, our discriminant is positive 5. So let's look at what we get when we have a positive value. We always get two real number roots. Two real number roots means that on the graph there will be two x-intercepts. That's what the roots are. They are the locations of the x-intercepts of that parabola. Okay, let's go back and look at the more specifics here. So we have positives, but now what we want to do is determine whether the discriminant is a perfect square number or not. So let's look at what we have. 5 is not a perfect square. So that tells us that we have this situation right here. If the discriminant is positive but not a square number, then the roots are irrational. Let's look at this other case here and let's achieve a square number quadratic. And I had one picked out in mind. Let's make a equal 4. And let's have b equal 7. And let's have c equal negative 2. That will give us a quadratic with a discriminant that is positive 81, and 81 is a perfect square. Now what that tells us is if a discriminant is a perfect square, the roots are rational, meaning that we won't need any radical notation, and that the quadratic, the original quadratic, will factor. So let's take a look at that and factor this. A is 4, so let's write it as 4x squared. B is 7 plus 7x, and c is negative 2. Minus 2 equals 0. Okay, so remember the technique said if our discriminant is a positive number and it's a square number, then this will factor. There's another video on factoring trinomials you can review. This one happens to factor to x plus 2 times 4x minus 1. And when I apply zero product property, I get my two roots. X equals negative 2, which is this root, and x equals 1/4, which is this root. And notice that we don't have any radicals, no square root values. If our discriminant had been a positive number that's non-square, we would have used our quadratic formula and we would end up with some irrational values that we can still do our best to graph. Okay, let's look at when we have not a positive discriminant, but a zero discriminant. We will have one real root, also called a double root, and this is also the location of the vertex. So let's go and achieve a discriminant that is equal to 0, and I think we can use some deductive reasoning here. Let's get this to be 4 minus 4. So let's make B 2. I think I can do it. Come on. No? Oh, I used to be so good at this. Let's try the mouse. There we go. Alright, B is 2. We have a square right here, which tells me that we would have a trinomial that factors, but we're interested in a 0. So let's make A 1, and let's make C 1. There we go. Now we have a discriminant that equals 0. And let's look again. When our discriminant is 0, we get one real root, also called a double root, and it's the vertex of the parabola, and that is exactly what we have here. And also from the video about deriving the quadratic formula, we'll also see that if we wanted the actual value, we could use negative b over 2a to get the x value of the vertex. And in this case, b is 2, a is 1, 2 times 1, whoops. And this gives me negative 1. And when we plug this into our quadratic, nice, we would get 0 as the output. So that is our root and our vertex. And that's the situation when our discriminant is 0. And our third case is when our discriminant is negative. In this case, we will have two imaginary roots, and our parabola will not intersect the x-axis. And we can achieve that, here we go, by making b equal to 1. And now we can see that the discriminant is a negative 3, and we do not have any intersections with the x-axis, meaning that there are no real roots. There are only imaginary roots, and you would use the quadratic formula to find those. Thanks for watching.